going? Phil Lanehart, JTech. This week we're doing diagnosing fault codes and repairing any kind of faults in that circuit. On this truck we're having an engine coolant temp sensor fault. It's a little intermittent, so we're going to try and get it on the reader. So the fault we get is engine coolant temp, voltage above normal or shorted high, which doesn't necessarily mean that there is a short per se in the wire. With this truck, it signifies actually that there is an open in the engine coolant temp circuit. So we're going to go take a look at it on the other side. So we're over here, we're going to start off by just looking at any kind of connections, any wires, see if there's anything frayed, kinked up, disconnected. Everything's connected fine, everything looks externally fine. So we're just going to do our basic test, our reference 5 volt. We're going to get that by hitting our reference pin, common pin. And as you can see, we're getting 5 volts. So we know our sensor is actually getting 5 volts. The next step is we're going to jump from our common to our signal wire and then go check the code. Common, signal, and by creating the short or jumping it, it's going to tell us that if the code changed, if we were reading the code, if it did change, our sensor is bad, we know that. And if it did not change, that means we need to do some further troubleshooting, getting our ECM and checking it there. So let's get to that. So we're gonna come over here. And we figured it's gonna be our P2 part of our ECM, the top part. We're gonna undo it and get to pin 14 and pin 30. Pin 14 is our signal wire and pin 30 is our common. We're gonna jump those two. Alright, so now we got it jumped between 14 and 30, our signal and common. We're going to go check our code, and if it changes the code, that means our ECM is actually reading that signal and the ECM is good. We need to troubleshoot further into our harness, our wire. If it does not change the code, that means our ECM is bad, it's not recognizing the signal. So we need to hook up a test ECM and go further in that way. But we know that our ECM is good, so now we're going to get into our wire troubleshooting and repair. So we're going to ohm our signal wire at one end at the ECM connector, at the other end where it connects to the sensor itself. And then we're going to see how much resistance we're getting across the full harness. We're ideally looking for a low reading overall. But if we do get an OL or out of limits, that does mean that there is a problem somewhere, that there is an open in that wire. This test, however, did not get recorded for whatever reason, but we did get an out of limits reading on the meter. So that tells us it is definitely our wire and there is a open in it. So we're going to get into our wire repair by first eliminate the old defective one by either depinning it or cutting it, and then we're going to replace it by either repinning it at the connectors, or we're just going to, if we cut it, we're going to use crimping with butt connectors and heat shrink. Another way is soldering by twisting the wires and using heat shrink as well. But some things to consider when doing this are the size of the wire. It needs to be adequate, both length and gauge, and also the routing of it as not to get it too hot or exposed to moving parts. Alright, so we diagnosed everything from our fault code reader, from the engine coolant temp sensor. We determined that the sensor was good, came to ECM, the ECM was good, and we found out that there was a problem in the harness, the wiring. And that's going to conclude it for this week. I'm Phil Lanehart. Thanks for watching.